All right. So once again, welcome everyone. Thank you very much for joining us today for this webinar with our brilliant guest speakers. Today we have not one, not two, but three speakers from a company based in Ghana called Aya Data. And to start with, as always, I would like to just quickly go through a very short presentation of what we do at We Robotics and with the Flying Labs as well. So before I hand over to you guys, you still have a few more minutes to prepare your presentations, to take a breath, and I'll just quickly present our work. Right, so first of all, I would like to start by explaining who we are. We are a social good or social impact organization that supports and connects local experts in drone data and AI technologies. And by doing so, we co-create a proven and replicable model to successfully localize and shift the power at a grassroots level. We amplify the power of local expertise to multiply sustainable solutions for development, aid, and climate, driven by local actors and supported by appropriate robotics technologies. So as part of what we do, as part of our mission, we co-create a practical approach aimed at responsibly and sustainably localizing emerging technologies, like I said, for the aid and development sectors. And to co-create such a solution, we needed a specific technology to focus on. And as we have a very strong passion for three technologies from a power shifting perspective, we focused on drones, data, and AI technologies. We also document our learnings and share our experiences and the model with other organizations to also the organizations that also want to push their localization efforts a little bit further and try out a bottom-up or decentralized power approach to localization. Speaking of the role of We Robotics, We Robotics acts as the Flying Labs network steward in a way, and our role is to grow the network and to turn it into a thriving, convening space. So much of our work is really behind the scenes so that the network as a whole, as well as individual Flying Labs, can grow and thrive. So now let's talk about the Flying Labs a little bit more. Who are Flying Labs? The Flying Labs act as the network members, and they are independent and self-funded. They join the network through a social franchise model, adhering to the network guidelines. And within these guidelines, they have full agency over their decisions and their activities. The Flying Labs network has grown from 3 countries when we started back in 2016 into a global network of around 40 independent knowledge hubs today. So it's already massive. And you can see more or less the map here on the slide here today, right now. What the Flying Labs do is they collaborate with the community partners in the humanitarian, health, environment, and development sectors. And each of the Flying Labs strengthens the local level capacity and tech expertise. They implement sustainable solutions with their communities, contribute to the local ecosystems, and share learnings across the network to catalyze that positive impact. And the last slide about the Flying Labs is something that we get asked often. So how are Flying Labs set up and how are they financed? So in line with the network's purpose, the Flying Labs are self-financed as they are hosted by existing local organizations that already offer professional services and education around emerging technologies. So in that sense, they remain financially independent by offering their own training, their own professional services to local governments, businesses, NGOs, universities, and possibly also other actors. So without further ado, I would like to introduce our wonderful speakers for today's webinar. We are joined by Freddie, who is the CEO of Aya Data, Simone, who's the product manager, and also Anthony, who's the account executive. And And with this, I'm gonna stop sharing my screen and allow you guys to continue the presentation. Thank you very much.
Thank you very much, Claudina. Can you hear me properly? Sorted out the sound issue. Welcome, guys. Give me a second. I will just share my screen and proceed with the presentation. Yes, can you see my screen?
Yes, we can.
Yes.
Once again, welcome, guys. I am Anthony. I work as account executive for IR Data, specifically under geospatial AI. I brought along very esteemed colleagues of mine, our CEO, Freddie, and Simone, who is our product manager. I will go into what we do as IR Data and the presentation, but first and foremost, I would love to know one thing, or a few things actually. For all the people, I see we have about 48 people tuned in. I would really love to know, like, tell in the comments, in the chat, you can tell us where you're from, what you do. Do you have any prior experience with AI, drones, or agriculture? If you're a novice and you have no idea about like what we do, can you like also tell us your favorite example of the application of AI in agricultural climate? We will be speaking about all these things, but we would love for the participants to navigate the conversation. And so please share in the chats. We will get back to it later on. And yeah, we want to have a very open communication line. And so, yeah, let me just jump right into the presentation. I know there are a lot of like experts on the call. So I am going to speak on what we do as IR Data, and then I go into the topic of the day. So who is IR Data? What do we do? We are a very young company in Ghana, based in Ghana. We specialize along the AI value chain, but specifically we build and deploy AI solutions using drone and satellite data to solve like very critical problems in agriculture, in climate, and other industries as well. We do everything in-house. We have a very robust team of about 150 data labelers. We have data scientists, DevOps engineers, and agri experts that we also partner with as well. And the unique thing about IR Data is with a lot of the things that we do, we build very custom solutions right from the scratch. We are able to field the wants of our clients and then build it according to their specification. We are very research based, and so we have, as you can see from what some of the institutions we worked with some of the biggest research institutions globally, including MIT and Imperial College in London. I don't want to brag, but we've also worked with the UK government as well as some pretty big names, both locally and internationally. But I don't want to bore you with what we do. I just want to like talk about precision agriculture. It's something I'm very passionate about. And so for the people on the call that might not be very familiar with the topic, I want to do some educating, right? So what is precision agriculture? Before getting into IR, I had never heard of precision agriculture, right? I grew up with a grandfather that was a farmer, and the only thing I knew was just taking a hoe and going to the farm. This was way back in Nigeria, but coming and learning about precision agriculture, it's important to know that farming is one of the oldest human activities, right? Dating far back as 10,000 BC. Human beings have always found the need to cultivate the food that we eat, right? And just like farming 10,000 years ago, we continue to evolve. And the evolution comes with us looking for much more effective ways to plant, much more effective ways to generate like crop yields and stuff like that. And then you ask a question, why is there a need for precision agriculture? In order to understand why there's a need for precision agriculture, we have to also understand what are the current challenges in traditional agriculture in Africa, right? And before the presentation, I spoke to a number of farms, spoke to a number of like our partners as well, our consultants, and across every across every region, across every sub-region in Africa, every problem is unique in terms of what their farming is dealing with or their farming system is dealing with. But four problems I saw that cut across board were these four problems, right? So poor data management, waste of resources, soil degradation, labor cost and accessibility, right? And if you pay very close attention to the challenges that I just listed, you realize something. All these challenges are jointly linked. They are linked to each other, right? So where there is poor data management, you can be guaranteed that you will have the waste of resources, right? Where there are no effective data to back some of the decisions that are being made on the farm, it will lead to waste of resources. I'll give you a typical example. So you have a plantation, 5,000 hectares, right? That are still very much using old ways of traditional means of agriculture, and there is a disease outbreak on the farm. What do traditional farms do logically? They spray the whole farm, right? And spraying the whole farm, on paper, it sounds good, right? But if you look into it, you realize that some of the problems that cause soil degradation, which is one huge challenge, is what the over application of fertilizer, the over application of pesticide, right? But in a system where you have data-driven decision making, where precision agriculture and AI in precision agriculture can help you know the exact block in your farm that needs to be, like, let's say, to be sprayed, right? So you know that rather than spraying a 5,000 hectare farm, you can just specialize on like one or two blocks where you have discovered is the origin of the problem, right? And believe you me, this is a problem that is very much prevalent, especially in this part of the world. We speak to farmers consistently, and one thing that we'll tell you is there is there is no accurate system that properly captures the data, stores it, and gives insights to these farmers on how to better their yield, right? And I'll share statistics with you. The Tufts University in Massachusetts, US, published a research that said farm practices that use data are expected to reach $2.3 trillion in terms of annual cost saving, right? And guess what? AI and data analytics is going to contribute to $250 billion of that 2.3 trillion, right? It should just give you a general idea of how important AI, how important data analytics is in modern day farming, right? I've spoken about the benefits. As you can see, it's data-driven decision making, resource optimization. These farms are able to know where to apply this solution, where to apply this solution as well, when to know which part of their farms need spraying, which part of their farms need different things, right? And in the end, it leads to environmental sustainability, which is something we are very big on at IR Data. We are making sure whatever solution that we are trying to produce is helping the environment, because we only have one Earth, right? And so whatever thing we are trying to do right now is geared at sustainability of the environment. I've spoken about all these fancy things. I want to also take you through real life AI applications for people that this is a very new subject to, right? So it's easy for me to say, oh, AI does this and big data does this and we do this and we do that. What are some of the real life applications you can find in your everyday farming, right? And the next slide does exactly that. Sorry, one second. Excellent. So what are some of the applications of precision agriculture currently? There are numerous applications, but these ones I personally handpicked because I feel like these are the ones that are most fascinating and are the ones that are widely being implemented currently, right? So we speak about object detection. This is where you have companies that have developed solutions that use image recognition systems to be able to detect weeds. So for example, you have a company in Europe, they are called EcoBots. We saw them as part of the companies that we work on. So what they do is they have a system that they have an AI model that they've trained, right, to be able to identify, let's say, the plants wheat or cassava, for example, right? The AI model is being able to is able to be trained on how to identify what the wheat plant looks like and what wheat looks like as well, right? So when this is done, this mechanism is implemented on like a put on a tractor, right? Where they do like they do precision spraying, and they can spray across like a whole farmland, and only the weed is being targeted, right? And think about it. It solves the problem of over-fertilization, overspraying of pesticides. And apart from this, you can also use it in disease detection, right? Where like very key diseases that are very tailored to specific crops can be identified. And once the diseases are identified, you can train a machine learning model to be able to tell, okay, in bananas, this is a cicatua, right? And this is a disease in bananas. So once you fly like a drone over it, you can always tell that, okay, this plant is diseased, this plant is diseased, or this block is diseased, and this block is disease-free, right? And it just goes to show you what I was speaking about previously, about the effectiveness of precision agriculture and how it saves time and cost. Moving on, I would like to speak about drone and satellite. This is a very, I can see Simone grinning already because this is one aspect that she loves a lot, especially having to do with what we do here at Data. So there are a number of solutions that we have been able to figure out in terms of plant count, blank spots, and terrain analysis, right? Where we send out, or farm plantations send out drones. These drone capture images that we are able to use to create a model to be able to identify things like plant counts. It can tell you, Simone will speak on that later, but basically tell you how many plants, how many crops are in a particular hectare, how many trees are in a particular block. And blank spot analysis tells you which part of your plantation needs replanting. Terrain analysis shows you which just the basic geographic features of your land. Where is the best place to plant? Where is the best place where is the best place that proves that there is more soil moisture and stuff. And then we go to IoT sensors. What are IoT sensors? In simple terms, IoT sensors are Internet of Things. They are these devices that are planted either on the farm or on different other like vehicles, right? That are able to give you information on specific things in the farm. And I have a very interesting like use case, right? So one of the very prevalent problems in oil palm is the red palm weevil, right? And is this insect that caused a lot of problem in the palm industry. And one very interesting use case with IoT sensors is being able to identify a tree that has been, let's say, practically been infested with red palm weevil is difficult, right? And so sometimes it takes months before these people are able to know, okay, this tree is infected, this tree is not infected. Now, one very interesting application of sensors is there is an autonomous bioacoustic device, right, that can be planted on trees or planted on vehicles that is able to listen to these palm weevils and the sound that they make, right? So if, let's say, this particular block is suspected of having a red palm weevil infestation, they implant these devices on the trees, and these devices can listen and tell, okay, this tree is infested, right? So the tree doesn't even have to get to the stage where it's unsolvable. The problem is like unsolvable, right? And they're able to use the sound that this produces to tell. Sensors can also be used in different ways to check soil moisture, as well as different bits of agriculture. And now I want to speak on the last application. This is my favorite application because, like I said, I grew up with my grandfather who was a farmer, and something that was very typical was you being woke early hours of the morning to go to the farm and go and pick ripe oranges and stuff, right? And this application is very close, dear to my heart because it's something that is being implemented right now. We have a client that we work with on Raspberry Pecan, and if you know anything about raspberry picking, it's difficult to pick, right? And uh, companies such as Dogtooth are developing products, developing robots like this that can go into the farm and detect if the fruit is ripe, if the fruit is unripe, and at what stage it is, and then do the picking for you. And what does that do? It saves you time on a lot of like mundane tasks that you initially would need a human being to do, right? These are all different applications of precision agriculture, but I'm sure you're tired of hearing my voice. I will let Simone come and show you what we as Aya Data are currently doing to in the precision agriculture space. Our solution, she will tell you more about that. So Simone, over to you.
Thank you, Anthony, for all that education. Um, Once again, my name is Simon Fuga. I'm the Agric product lead at Aya Data. My role basically revolves around understanding what our customer pain points are, what their needs are, converting that into amazing products and delivering that with my amazing team. So with our labelers, our data science team, our software developers, and our marketing team, basically building and launching these solutions to meet and exceed our customer needs. I'm very excited about the potential for AI in agriculture, as Anthony has, very nicely explained. There's a lot of challenges that agri stakeholders face. You have low productivity levels, which obviously leads to yield, low revenue, inefficient use of resources, wasting of resources, affecting the environment, etc. So there's actually a big demand for AI-driven tools and platforms and solutions that can basically help farm owners and all other agri stakeholders to make data-driven decisions that can really drive impact, right? And for us, impact looks like saving costs or saving on costs for your inputs, optimizing your resources. So as Anthony has explained, using, you know, targeting specific areas that have issues and using your resources, in an optimized way versus just blanket application, and then also improving your yield and your revenues. So what I want to do is help you understand a bit practically how AI-driven technology can help agri stakeholders convert insights into tangible results. This is an approach that we are taking in the development of our solution, and we're actually building an AI crop monitoring solution, which we'll be launching hopefully by the end of this year. And we'd love to also share that with you with all of you once we do that. So that's something to look forward to towards the end of the year. You'll be hearing from us with our Ag AI platform. But how, so there are four main things that I want us to look at. So that's capturing data across space and time, analyzing this data through AI models and advanced analytics, being able to generalize and visualize these insights via geospatial dashboards, and then how you can take action and actually create value, throughout all this process. So first is data acquisition. I think Anthony has mentioned the many ways that you can collect data. So you have drone data, you have satellite data, you have sensors, you have robots. At Aya Data, we are more focused on drones and satellites. And for me, the key points here when capturing data, data quality is very key. And when you're using, data for AI insights, for instance, you need to consider the height of flight. So if you're doing a count model for oil palm, you want to be flying at about 100 meters above ground level. But if you're doing that for banana count, bananas are shorter, it's a shorter crop, so you're going to be flying at about 40 to 60 meters above ground level. So the height of your flight is very important, and those are things that you need to consider when you're collecting data in an AI-driven solution. You also want to consider the format of your data. So you have drones that have RGB data or multispectral data. So for count, for instance, you can use RGB data for count. However, when you're looking at, let's say, plant stress, water stress, nutrients deficiency, then you're going into multispectral. So being able to use NDVI to basically assess whether a plant has, certain nutrients deficiencies. So these are two things that you should think about: what height you're flying at, and what type of data you're collecting, whether that's RGB or that's multispectral. So once you collect the data, you want to run that through your AI models. And at Aya, we're building these AI models in-house. I think Anthony has also mentioned that we have a team of 150 labelers. We have data scientists. We have software developers. So we're able to build the AI models in-house. Some of the models that we're looking at currently are count models, health analysis, nutrients deficiency, and that's across a few crops. So oil palm, mango, banana, rubber, and we're very interested in speaking with all of you. If you actually have like other crops that you want to talk about, we're very open to having discussions as well. So hopefully after the webinar, you can let us know what kind of crops you're working with, and we can also look at how we can support you to develop solutions in that space. But how do we, so just quickly, how do we go about building these models? I want to use an example of, how do you teach a child to learn something, right? You need to feed it a lot of examples. You need to give it a lot of examples till it learns. So one of the things, in building AI models, what you need to do is collect a lot of data, label that data, and then use that to train your models to learn how to identify certain things, right? So if that's identifying a palm tree or identifying whether the palm has, certain levels of yellowness or certain levels of dryness, which is an indication of its health levels, right? So that's how we build our AI models. There's also an element of ground truthing, which is how you assess the accuracy of your models. So you need to be able to collect data from the ground to actually, assess whether certain trees have these deficiencies or whether they actually have these pest and disease infections. And that's a way that you use to validate and validate the accuracy of your models. Just another thing to mention about building AI models, it's a very iterative process. So, for instance, our AI models are built on oil palm trees in Ivory Coast, Ghana, and China. However, you may have trees in Malaysia that may be a different strain. So you need to be able to, continuously fine tune and retrain these models to make sure that they cover different strains, right? So a model that maybe can count oil palm in West Africa may not be optimized to count oil palms in Malaysia. So that's also something that you need to think about, optimizing your models and making sure that they cover different use cases. So once you collect your data, you run it through the model. Now you want to be able to visualize, what the results are, right? And this is where, geospatial dashboards come into play. You can visualize that on a map and be able to actually see, the location of each tree. You can see, what kind of infestation is affecting the tree. Is the tree healthy? Is it not? What is the specific nutrients that is missing in that tree? And we can really do that at a tree level. So you'll be able to identify the tree and be able to detect the specific issues that are related to that tree. I'll show you a dashboard that we've put together for one of our clients for Count, and hopefully that will be able to give you a better idea of what I'm talking about. But ideally, for visualization, you want to be able to identify the areas that have specific pest and disease infestations or low nutrients levels or high water stress or plant stress. And then that takes you to the next step, which is taking action and creating value, right? So once you've been able to visualize, where certain infestations or where certain problems are, you can actually send your teams to these specific locations versus kind of doing a blanket, inspection across your farm. And this really comes in when you're dealing with, farms that are, over 1,000 hectares large, it's just easier to be able to automate these kind of insights, and it really helps in saving resources, saving costs, saving inputs, saving water, etc. So that's just a quick kind of overview end to end on how we help organizations convert AI-powered insights into tangible results. I want to show you one of the dashboards that we have, as I mentioned. So Anthony, I will share my screen so that you. Okay, so this is a dashboard that leverages ArcGIS, which is one of the amazing visualization tools out there. Just to mention, we're very flexible in how we generate insights and how we generate outputs. We have clients that already have existing systems that may want an API connection, so we can do that. If you want an ArcGIS dashboard, we can do that. If you want a PDF report or a CSV, we can do that. But as I mentioned, we're actually building a SaaS platform that would have all of this integrated into it by the end of the year. So, but just to give you an idea, our clients came with a challenge. They have about 7,000 hectares of oil palm, and they were actually having to do oil palm counts every 4 years. And they would ideally want to do that more often, right? But counting palm on 7,000 hectares is quite a tedious and manual task. So that was where we came in, and we were like, okay, we're going to help you, you know, automate your count and use drone imagery to basically do this counting. And we're able to generate, this is actually the POC, but we were able to, within 2 days, generate counts for them over 1,000 hectares. So comparing 2 days to 2 months worth of work, you can really see the value that AI can bring. So what we did was we collected a whole bunch of data. We trained our models in-house, as I mentioned, used ground truth to validate these results. And we were able to present them with a dashboard. You can see, each dot here represents a tree, a specific tree, which has a unique ID. You can click on the specific tree and you can see the details of that tree. So, which block it's in, what's the palm ID, what's the specific location, so latitude and longitude of the tree, what's the diameter, the crown diameter, what's the height. The height was generated using LiDAR data, and then using an algorithm that factors in diameter, height, and other information, we were also able to assess the maturity of the tree, whether it's a teen, mature, or young. So this shows you how you can, use AI to gain insights and to take action on your farm. You know where this specific tree is. If there's an infestation, you'll be able to see it. If it has a specific, pest and disease, or it has a specific nutrient deficiency, you can also see that here. And then you can send your team to these specific locations for them to, capture data, capture observations, carry out specific treatments that you want to do. And as I said, the ultimate aim is to help you to reduce your costs, to reduce your input usage, to reduce your labor costs and improve efficiency on your farm. So this is just a quick kind of overview of what we do. And I will be handing over to Freddie to talk about some of the case studies and some of the SDG related stuff that we're doing as well. So thank you very much. Over to you, Freddie.
Excellent. Thank you very much, Simone and Anthony. I hope that was informative and clear for everyone, and hopefully interesting as well. Anthony, are you able to present the deck again, or shall I find it on my laptop? Or Simone? Aha. Wonderful. Okay, thank you very much. I'm going to try and whiz through the next few slides because really I think the best part of this webinar, I hope, will be interactions with all of our 62 participants. But just before we get to the end point, I think this slide is really important because we've heard why precision agriculture is important for farmers. It's also important to reflect on why it's important for all of us around the world. I think all of these points are fairly straightforward, but it pays to reiterate them. So climate is becoming more of an issue day to day. Agriculture is one of the primary drivers of climate change in some senses, and will play a huge role in combating change to our ecosystem. So you've already heard about soil degradation and increasing yields. Essentially, we as a species need to learn to use less land to produce more food, and that's going to help us save the planet, to preserve biodiverse areas and other things that all of us care about. Producing more food from less land is also something that's going to help us preserve our population. You know, there's a huge amount of people on the planet. I heard a stat the other day, which you probably won't believe, but I encourage you to look it up because I think it's interesting. There are more people alive today than have ever died. There are more people alive today than have ever died. So you probably doubt that. I certainly did, but it's not even close. So if you think about how population is increasing year to year, decade to decade, it's absolutely insane. And we have to build systems powered by advanced technology that are going to allow us to provide for all of those mouths. So this technology is very important now, but it's also very important to develop it for future generations so that we can produce what we need to produce to keep people fed. And lastly, it's about economic growth. So if you as a farmer can create more value for yourself, your family, and for your economy, and indeed create more value for the planet in producing more goods, that is a good thing for everyone. So I think there's quite a clear link from the commercial side of this to the social side. And it's very important, I know, to IAData and also to everybody probably on this call at Flying Labs, that we link the things that we're building to sustainable development goals. So Anthony, we can go on to the next slide now. Okay, brilliant. Well, look, I've got a few slides. We're going to go through them quite quickly. Simone has shown you a little bit of what we have built. One of the things we've built for clients that was really focused on palm oil, but there's a whole range of things that we have already built and that we specialize in. One of the things that we're very excited about is forestry and how AI, drones, and satellites can be used to improve the efficiency of effectively rearing trees, either to use in construction, etc., or to sequester carbon. So we're working with Oku Environmental, one of the largest reforestation companies in West Africa, particularly on their Sierra Leone project, which is a 32,000 hectare site. Oku's problem was that they wanted to understand how many trees they had, whether the trees were germinating correctly, how quickly the trees were growing, and various other things. So that is exactly what we've built. We use drones, and similarly to the dashboard that you saw Simone present, we've built maps of where all of the trees are, which trees need to be replanted, and we're building a system to accurately measure carbon biomass and growth rates in those trees, as well as the species of the trees. So you're going to have, just way more information about forestry projects than would have been accessible even just a few years ago, all through computer vision algorithms applied using drone data. So I think we can move on to the next one. I think with all of these, the point of showing them to you is that, we hope that you see value in this and that you've seen demand for these sorts of services, and that we can work together on deploying this all around the continent and indeed globally. The second case study that we wanted to talk about, which we find very interesting, is something that we're currently working on with Imperial College London and the largest organic banana farm in the world, which is based in Ghana. The key here is to count bananas. I think Simone mentioned that counting bananas is very different to counting palm trees, not just because they're shorter, but because their canopies overlap. They're extremely dense, and they're plants, they're not trees. They have no single central stem to them. So the algorithms that you need to train have to be very much more accurate, and it's a little bit more complicated. It requires much more data, but a really fascinating project. So we hope by the end of this, by the end of Q3, to have a production level banana count model, which to our knowledge will be the first that will be commercially available at a production level. There have been some research projects into this. And already we're working with our client and with Imperial to look at nutrient deficiency detection as well. So the main use case for the client is to count the trees, or the plants rather. They want to do this regularly because banana plants can be destroyed by anything, including bad weather, etc. It's important to know how many you have to predict yield, and also to see which plants need nutrients and which don't, so you can control fertigation and therefore save money. So we'll skip on to the next one now. Thanks, Anthony. This is a really interesting one. It's using satellite data. So many people on the call will be aware of the EU deforestation regulations, sweeping reform put into place by the EU, which means that you cannot import any of 7 chosen commodities without proving that they did not result from deforestation. So for instance, with any bit of rubber or palm and many others, you have to, or cocoa, you have to prove that your import did not come from a farm that was, as a result of deforestation. So that involves mapping the farms with satellite data, making sure that you can trace a cocoa bean back to that farm using traceability software, and then validating that that farm has not caused any deforestation since the end of 2020. So really fascinating project. Delighted to talk about this with anybody on the call now or indeed afterwards, but it's a very tricky problem, and we've got a great solution. And then the last one is a bit of a left field one, honestly, and not something we sought out, but somebody found us as a geospatial AI company, and they gave us a slightly bizarre asset management task. They wanted to use drones that collected LiDAR data as well as RGB data. LiDAR, for those of you who don't know, creates a 3D point cloud of anything it flies over. So you can see the shape of things and the condition of things. And this company wanted to measure the condition and position of gravestones and gravestone assets in 4,500 cemeteries in the UK. So it's a problem that's cost them tens of millions of pounds each year for the past however many years. And now we've developed a system with them whereby we can do all of the monitoring of the condition of their assets using drones and our analytics software. And this will be displayed in their front end, which you can see there on the right. So a bit of a different one. The reason I wanted to include this is because it just gives you an idea of how broad the scope of AI is, whether it's helping to predict yields or counting trees, to measuring the condition of assets, whether it's gravestones or pylons or roofs, anything else. So these are all the things that we love to build. These are all the things that we love to talk about. And yeah, we're very excited to hear everybody's thoughts on these. So in conclusion, what do we want to get out of this webinar? Really is to hopefully give everyone something interesting to think about with regards to precision agriculture. We'd also like to hear from people and build connections with people who want to use this sort of technology either themselves on their own assets or their own farms, or with their clients. For instance, if you're a flying lab somewhere on the continent, you have clients in agriculture or who would benefit from an asset management solution. those are the conversations we would like to start. I think the last thing to stress has been stressed by both Anthony and Simone. We're a very unique model in that we build everything from Ghana, which means we can build these solutions without outsourcing anything to anyone, which means we're cheap, we're quick, we can build from scratch. So all of the stuff you've seen, we've built very quickly and deployed it very quickly for a pretty unique rate. So that makes it very exciting to experiment from our perspective and hopefully from yours. So I'm going to stop rabbiting on there. I can see that we've got a few bits in the chat. I don't know if they're questions. Simone, I think, has answered them. But yes, I'd like to hand over to the audience, I guess, to see if anybody wants to ask a question verbally or focus on anything we've talked about. I can see that Roy has got his hand up.
Yeah, Freddie, how's it going? How are you?
Doing very well, thanks, Roy. How are you?
I'm fine. Yeah, hey everyone. I'm Roy. I work at Aya Data, and I just wanted to know if the company is aiming towards collaborating maybe with the Ghanaian government on planting for food and jobs. And I wanted to ask how these solutions are going to help the climate effort in Ghana.
Yeah, so I think just to answer the first question, the Planting for Food and Jobs initiative, for those of you who don't know, is effectively investment in agriculture in Ghana led by the government, whereby they subsidize fertilizers and things like that. It's not a program we've looked at collaborating with the Ghana government on. However, we have been speaking to the Cocoa Board, which is the major governance body for cocoa growth and sales in the country, to really see how we can improve efficiency in cocoa growing, which is the main crop, cash crop within Ghana. So that's something that's really exciting for us. And of course, improving efficiency equals good environmental outcomes as well. So the two really go hand in hand.
All right, thank you.
William Orr from Ecom, he's got his hand up.
Hi, Freddie. Thanks, Simone. Thanks, Anthony, for that presentation. It was great to hear. But I just, one of the things that we're currently exploring is around biochar. So working with coconut farmers in the western region of Ghana with the ambition of then doing a digital MRV solution that monitors from the purchasing right through to the application. I just wondered what kind of model you would look like, and maybe if you could have had any sort of input or first thoughts along those lines, just at the moment.
Thank you very much, Will. Well, it's a great question. I'm happy to take it. We've not looked at doing a DMRV yet. I think it's a fairly saturated market, and I'm sure that you probably know some of the major players who specialize in that. But what I would say is that it's somewhat similar in terms of traceability and tracking to some of the things that we're building and collaborating with partners on with regards to EUDR, which I briefly spoke about earlier. So very happy to jump on a call if you'd like to go into that further and hear where you're at with your project, etc.
Yeah, that sounds great. And just with your EUDR, how exactly are you measuring deforestation? I mean, how are you sort of marking that? What's your sort of marker back you're going to on that at the moment?
Yeah, it's a really good question. We've ummed and ahed about it because the EU, as you know, probably working for Ecom, is, they like to make rules broadly, but they don't like to give many details. So there are no clear set criteria as to what constitutes deforestation. So what we've done is we've created a system that will grade farms initially based on high risk or low risk. So if you're a farm and you're in the savannah, you're very low risk, and we can tell that using quite low res satellite data and matching that against topographies. But if you're a farm, say, and you're in a protected forested area, then our system will filter you into a pile where we get very high resolution satellite data, and we'll be able to look in detail at your farm and try to observe whether deforestation has taken place. And answering, what that means at the moment is still somewhat nebulous, I think, across the industry. But we have a bunch of different tests that we'd run in terms of, is there more or less foliage and foliation around the farm that used to be not part of the farm, etc. Things like that. So I'm happy to share that with you afterwards if useful.
Yeah, thanks. That's super interesting. Thanks, Kim.
No problem. Any more questions? Sorry, go on.
I was just going to suggest maybe you can share your email or some contact details with everyone so that people can reach out to you after the webinar if they're interested.
Yeah, absolutely. Will this be shared round, Claudinia? As in, will the deck be shared, etc., or not?
You mean if we can share it with the participants later on?
Yeah, is there a way for us to, should I just put my email address in the chat now?
That would be
the easiest
best.
way?
If you can do that, that would be best.
Got it. Done.
Thank you.
And if you'd like to contact Simone or Anthony, I think you'll be able to work out how to do that from my email.
Yeah, I've added my email address as well to the chat. So. Please feel free to get in touch. Talk to us about what you're doing. I'd love to help have conversations, explore solutions.
Great.
Nice.
Well, thank you so much, everyone, for listening to us. Really appreciate it, and hopefully we'll be in touch soon.
All right, and thanks to you, Freddie, Simone, and Anthony. Thanks for your time and the great presentation. It was a pleasure hosting you during this webinar. And thanks everyone for spending the last hour with us. I see that there maybe we still have time for the last question. We still have 3 minutes to go. Could we take one more question? Awesome.
Sure.
So Gabriel, over to you. Gabriel, can you hear us?
Gabriel, if you're trying to speak, you have to unmute your mic.
Yeah, sorry. I hope you guys can hear me.
Yeah.
Hello?
We can hear you now.
Yeah. Okay. Well, so I'm in the central region. I do have a big farm. Yeah. I do have a big farm in the central region. And at the moment, we're trying to roll out to the Volta region. We do vegetable farming, both greenhouse and the open field. And with the climate change over here in the central region is really affecting our crops in the open field. And want to know if there could be any data sharing with Aya Data that can help us as a farm to, mitigate this problem, get to know whether if our plants on the open field are really suffering with the heat this year or with more pests, because almost 80% of the crops we did grow on the open field have really suffered. And we're trying to still revive some of the plants up with fertigation and all that. But we still can't really pinpoint whether it's because of the too much heat or pest. But so far, we've realized like it's not so much pest because we do timely spraying, but our plants are really suffering. So we don't know if we can have a collaboration with Aya Data where we can find solutions to this on our farm,
I'm happy to take that one just quickly. Yeah, I think the answer is absolutely yes. We should jump on a call. We also have partners in Ghana who are agronomic specialists in all sorts of different crops, including vegetables, who be able to visit your sites and give you some advice on that. but yes, and on the data side, very happy to share that with you as well. So please do get in touch.
Right, and that's it. I think we reached the point where we're out of time officially. So once again, thank you all for joining us today, and have a great rest of your day. Thank you. Take care.
Thanks, bye.
Bye bye. Bye everyone.